So my name is Klaas. I'm a linguist. I work on my PhD at the University of Amsterdam. And I think that being a linguist entails two things. The first one is that I work with languages. The second one is that people often ask me how many languages I speak. Actually, the third one, thank you, Whitney, is people are scared that I will correct their grammar all the time. This may sometimes happen. Not all linguists do that. What I do think is true for all linguists is so indeed that they work with languages and that people ask us a lot how many languages we speak. So what many linguists do is actually compare data from very different languages and try to find patterns and also try to explain those patterns. So they try to kind of figure out what very different languages have in common and think about why this might be. So yeah, that's one thing that many linguists do. There are also other kind of mean linguists who come up with sentences like the one I started the name of my presentation with. For linguists, this is a very famous sentence, and actually it comes with another sentence. And it's quite likely that as you're reading this, your brain is kind of short-circuiting a little bit. And why? Exactly. Yeah. Yeah, it's a tricky one. And why is it a tricky one? Because some words occur in both sentences, and they sound the same. They're also written the same. But they're very different categories of words, actually. So flies in the first sentence is a verb, but in the second one it's a noun. And like in the first sentence is a conjunction, so it compares time with an arrow. And in the second sentence, like is a verb. So they look very similar, but they're not at all. So there's also a group of kind of mean linguists who come up with sentences like these and then figure out what happens in the brain as we process a sentence like this. I'm not one of those mean people, of course. So in the 50s, 60s, so the 1950s, 60s, linguists kind of figured out that languages did seem to have quite a bit they seem to share quite some properties. For instance, they figured out that all languages seem to have nouns and verbs, and they also figured out kind of, let's say, hierarchies, like if a language has gender, meaning that the language marks the difference between he and she, that a language will also have number, meaning that they mark the difference between I and we, for instance. So they have different words for those. Or in certain varieties of English, you have the difference between you and y'all. That's marking the number property. So that was one thing that kind of happened halfway through the last century. Another was that there was a big debate going on about how children learn language. So on the left here, you see Skinner. He was a behaviorist. And he kind of argued that children learn language by observing their parents and kind of copying what they do. So basically by imitation. And Chomsky on the right, who is probably the most famous linguist of the last century, and maybe even this one, although we've only just started, he disagreed, and he said, well, children can actually produce sentences like that they have never heard before. So it can't just be imitation. There must be something more to this. And as a solution to kind of both these observations, Chomsky came up with the idea of a universal grammar, or UG, which basically means that every human is born with a language faculty, language organ it's sometimes even called, meaning that the possible design space of language is kind of hardwired into our brain or into our DNA. So in that case, it means that when you learn a language, you already kind of know what the options are. You have like an idea of all possible options, but you need to figure out which of those apply to your native language or languages. Yeah, so it's already hardwired into your brain. So you basically already know, okay, my language has nouns and verbs, something like that. There has been a lot of criticism on that position. One of the criticism has to do with kind of the sample of languages that linguists have based themselves on. We call these languages weird, where weird stands for Western, educated, industrialized, rich, and democratic. So the language that we probably know most about is English, most likely. Other Western languages we know a lot about too. So languages that are spoken in countries that are Western, educated, industrialized, rich and democratic, they're just easiest to access for us, right? So, I mean, it's easiest to find data about those languages. And I mean, we assume that there are about 6,000 languages being spoken in the world right now, but I wouldn't really dare to make a guess, but a very, very large part of those languages has not been described yet. Maybe because they're hard to reach, like geographically or physically, or maybe also because there's just no money for any linguist to even go down there and do field work. So yeah, actually we don't really know that many languages. And as we found out more and more about different languages, we also found out that they seem to do very, very unexpected things now and then. So for instance, we know now that it's not true that all languages have nouns and verbs. And for instance, we like to think that the present tense, so when we talk about like the now, the present, that's kind of the standard. So for instance, in English, I can say I talk, and that's about what I'm doing right now. And when we're not talking about the present, we have to add something. So I can say I will talk, or I talked. So that's the future or the past tense. We need to kind of add a little bit of extra information. And a student of mine told me this week that the language that he's investigating actually marks when it is non-past or non-future. So actually when they are talking about the present in this language, they need to add something, which is very unexpected from, well, at least the point of view of all the languages that we seem to know well and like to work with. So that's a pretty big issue. I mean, we have more and more data, and it just doesn't really seem to be true that properties really hold for all languages. Another one is slightly more philosophical. So Bertrand Russell was a philosopher, and he was engaged in a theological debate. And he came up with the idea of what we now call Russell's teapot. So he argued that he could very easily claim that there is a teapot orbiting the sun between Earth and Mars, and it's so small that our telescopes cannot observe it. So it's there, but we can't really see it. And the point that he was trying to make with this is that it's kind of bad practice to make a claim that cannot be falsified. Because, I mean, how are you going to prove that's not true? The teapot is too small to be observed by us. So how are you going to prove that it's not true? And I think that you can actually also say this about universal grammar. I mean, show me where it is. You cannot prove that it's not there. So, yeah, I think that's a kind of philosophical, tricky aspect of the theory. Of course, alternatives have been proposed. There's been a huge group of linguists who kind of argues that we should look at language from the point of view of its function. Because, I mean, we use language for communication, right? We want to tell each other stuff, ask each other stuff, make someone else do something for you. That's what we use language for. And so it seems to be the case that if there is anything, well, I don't even want to talk about universal because it seems kind of too strong of a claim, but it does seem to be true that tendencies in language we may be able to ascribe to just its function. So very, very many languages have different ways of encoding the difference between a statement and a question. So they do that in different ways, like you do in English. Because for the people, or the person that you're talking with, or the people, it's important to know what you kind of want from them, right? Are you just telling something, or are you requesting something from them? What also seems to be true across languages is that they have vowels and consonants, which I guess is kind of nice because like an uninterrupted string of vowels is probably not really easy to listen to. So it's kind of more about what works in communication. And a few nerd nights ago, Mark Dingemans was one of the speakers here. And he and his research group from Nijmegen may have found a universal word, question mark. The sample that they looked at wasn't huge, but it does seem to be the case that languages have a way to signal a breakdown in communication. So when something goes wrong, you don't understand, or you can use this word, you can say something so that the person you're talking to kind of knows, okay, wait, I need to go back one step and make sure to fix this. And apparently, when languages do that, the word that they use for it sounds something like huh. So that may be a universal word. There's something else going on in language as well, and for that, we're going to do a little audience participation. Yay. That's going to be easy enough, don't worry. So when I show you the sequence 1, 2, 3, and I ask you to continue, what do? Jump. Jump, that's an option. Didn't think of that. How would you continue? 4, 5, 6 is a very likely option. I also heard someone say something with 7, I think. 37? Why? I don't know. Okay. There are actually multiple options, right? So, I mean, 4, 5, 6 is kind of an obvious one because it's just like the cardinal number from the decimal system. I think most people who aren't nerds will just say 4, 5, 6. Many people will maybe continue with this, part of the Fibonacci sequence, also an option. Maybe it's just repeating the numbers 1, 2, 3. We don't know. I mean, all we know is 1, 2, 3, right? So there are multiple options in principle. So you could actually regard all these options as kind of hypotheses about what the structure of this little data set 1, 2, 3 is going to be. And they all have kind of their own probability. So some are more likely than others. 4, 5, 6 is probably the most likely one. So we say that we have a bias towards certain hypotheses just because we consider them to be more likely. And in Edinburgh, some cognitive scientists actually figured out a framework to test these biases, kind of figure out what they are. The framework is called Iterated Learning. And they kind of base themselves on, the way that we learn language in the sense that, at least speaking for myself, I learned Dutch from my parents, who learned Dutch from their parents, who probably also learned Dutch from their parents. So we kind of have this transmission with every generation, right? From your caregivers, you learn language. But every person, every generation has these biases. I mean, they're biased towards certain hypotheses, which also means that every time that a new generation learns language, these biases kind of have a chance to, come into play somehow. And that they actually use exactly that idea in iterated learning, in like experimental settings, also computational research, where they have people come into the lab, They teach a certain language to this person. This person, of course, forms a hypothesis about that with certain biases. And then they ask this person to produce data. And the data that this person produces becomes the input to a new participant who then learns this language, forms a certain hypothesis about it, and then will produce his own data, which is then fed to a third participant. And so in every generation, with every iteration, these biases kind of get another chance, so to say. And a ton of research has been done with this framework. For instance, about learning mathematical functions, what the people in this experiment, the researchers actually did was not just like show participants a function and say, okay, this is y is x. What they did instead was show coordinates that belong to this function. So people would just see dots or crosses or something like that. And then during the test phase, they would be shown a value on the horizontal axis, and they would be asked to indicate what value on the y-axis would go with this. So they were basically asked to kind of recreate the function that they had just learned for different values, of course. And these researchers did this with a number of functions, and every time the coordinates that people indicated in the test phase became the input to the learning phase of the next participant. And in case of a basic, simple linear function like this, over a number of generations, nothing really happens. So this stays kind of stable. Now, when it's a negative function, you can see that already within a few generations, so actually the second generation does pretty well. The third one is already kind of starting to be in doubt, and then by basically generation 5, this has turned into a positive linear function. And once it has, it stays that way. That's also kind of important. So yeah, this is, I think, kind of spectacular. A cosine. Now, becomes a positive linear function, and once it has, it stays that way. And to kind of check, maybe, the researchers also tried a distribution like this. So just entirely random. And there they go again. So this way, because of the iterated learning, the kind of repeated transmission, we can see that apparently people have a preference for a linear function like that. Research like this has, of course, also been done with language. So a few researchers came up with a little language that had 3 meaning features. So you had 3 kinds of shapes, and these shapes could have one of 3 colors, and they could make one of 3 movements. So this means 3 times 3 times 3 is 27 different meanings. And what they did was initially, for every one of these 27 meanings, they kind of assigned a random label to it. And then had people learn this and transmit it. And over a number of generations, for instance, a language like this would come out, where let's say this word, Nekipilu, is the gray triangle making a circular movement. So what do you notice about this little mini language? What's happened? It's become kind of predictable, right? So everything, every meaning, every aspect of the meaning has kind of predictably become encoded in the word. So all the N words, those are gray stimuli, and the L words are for the blue ones, and the R words are for the red ones, and Pilu seems to be the squiggly movement. So what people did in this iterated learning cycle, through this transmission, is that they made it more learnable, because they made it kind of transparent in the sense that every aspect of the meaning was can be kind of recognized in the eventual language. So it's just become more learnable because, I mean, we like learnable stuff, right? That's a bias of ours, I would say. And I think that pressures like these also apply in other cultural phenomena, for instance, like music. Musicologists are much more hesitant to even talk about universals at all than linguists, which is probably a good thing. And but still, it seems to be true that there are certain tendencies there. So, for instance, the octave plays a very central role in many scales, because I mean, perceptually, we just kind of think of one note and the note that's like an octave away as basically the same note, right? So yeah, the octave is kind of a very central concept cross-culturally. And a regular beat also occurs in many cultures, so kind of an isochronous beat where it's very predictable. This may have something to do with the fact that humans are very good at predicting beats, whereas, for instance, gorillas aren't. So maybe that has something to do with it. And also, for instance, melodic lines tend to be pretty short, usually like 9 seconds or something at most, which may very well have to do something with memory constraints. So there, for instance, has been an iterated learning experiment where researchers had people listen to kind of irregular rhythmic patterns, so long and short beats kind of in random sequence, and then they had to kind of repeat those drumming. And after a few generations, people would kind of introduce some sort of nice structure into that. And it seemed to be the case also in, let's say, typological musical research, so kind of research that looks into the variety of musical systems that we find, that there is a bias towards, let's say, weird music. Yeah, here as well, I think we keep on finding out more and more, and there's more and more research being done about that. So that's very, very good, I think. I think we're going to find out a lot more about stuff like this in the next few decades. Yeah, so what I really like about working in linguistics is that there is so much diversity, and we find so much diversity in stuff that we kind of never thought was possible. And for instance, it's also very cool, I think, that language is so adaptable. So there are spoken languages that, for instance, can also be drummed or whistled. For instance, when people are too far away from each other to speak, like when your voice doesn't carry far enough, in some cases, people can drum or whistle that language. And of course, we have tactile language, and we have Braille, and of course, we also have sign language. There are very many different sign languages, and not only are they used by deaf people, for instance, but also by people in sawmills who can't really communicate with each other because the machines are just so loud. And these have become kind of full-fledged systems where they can talk about more than just, oh, this machine works like this or something. They can really communicate with each other fully, and I think that's really nice that stuff like that emerges when there is the necessity for it. So on that note, I am going to end with saying thank you and thanks.